All right. I've written about 1,000 lines of Golang so far in my life. I've mostly been working with Ruby, but I've written a lot of Golang at this point, and I wanted not a lot. I've just written enough so that I've learned some things, and I wanted to share what I learned. I'm gonna do a code review of the web application that I discussed a couple of days ago on this channel, which I'll link to in the description. So you should watch that first to understand what this app does. But this is the directory structure of the app. The first thing I'd like to discuss is how to, like, you'll notice that there are no .go files in the root here. Most of them for this application are in here in the package directory. Well, that's not what I want to do. This is gonna output some line counts of some files. So of my Go files, like most of them are in the package directory, and then we can see that I have a couple here that are in the command cmd directory. The cmd directory is where I'm putting files that I want to amount to separate binaries, separate executables. So if we go to my, the package has like source that's going to be shared by both executables. There's one called web server and there's another one called CLI. Obviously CLI is a command line interface, and web server is it's a web server. It's the app that I showcased in the other video. So if I go into CMD, you can see the two directories here. If I go into one, I have main.go here for CLI. I also have main.go here for web server. If I go into CLI and open this, I'm gonna work with package main. If I go look at the other one, it's the same thing. I'm working with package main over there. But because they're in different directories, you can build different executables for them. Let's go look at my make file that I've created for CLI here. I'm saying go build. I'm giving an output. So this is what I want the binary to be when it's done. And I pass in main.go from the CLI directory. For web server, it's the same thing. I just pass in a different source file and I name the resultant binary differently. So this is what gets me to having different binaries. And we can start to look at some code here. Like let's talk about how I'm importing my shared code. I'm importing package here, and then I'm calling package init from that imported package. Let's go take a look at how that happens. I have an init function here on the right hand side. This is in lookup.go inside of package. This is the one it's talking about. If I were to rename this to have an S at the end and say make, it'll say I can't find init, and if I fix the name, it'll start compiling successfully. How do I know? How does it know that when I'm talking about package that I'm talking about the directory pkg? To see that, we can go into my go mod. This is my go mod file, which was generated automatically. I made one edit to it, and then I pulled in another library and it corrected it to this. But the basic information is still here. I say, hey, please require pkg, some library named pkg, and this is an arbitrary version that I've assigned it. I don't think the version really matters. But at the end, I also say replace this package, this pkg library, with this, and I give it a relative path. And that's how it knows when I say, hey, when I'm going to import that, just go in this directory, please, and use this as the package. Also, at the top here of all of the source files in here, I'll say, hey, you're talking about the package. And I don't know what happens if I were to put an S there. I'm not sure what it would do. It gets mad. I think it's mad because you can't have more than one package inside of a directory. Anyways, so this is how you achieve shared code between two binaries. Let's start to walk through some of the functionality. I'm using OSR. I used to pull some arguments off of the command line. This is the CLI. Parse time is just what it sounds like. You could look up how to parse time on Google. Get qualifying video is a little more interesting. Like, this thing is hitting the Twitch API, so I'd like to talk about how, what does it look like when you go to access an API, like with OAuth 2. I would like to cover that. So what we'll see here, when I call get qualifying video, the first param is a username, and I go and get all the videos for that user on Twitch. We come in here. There's this call to get. And I get back response body, which is a byte array. But let's see if we can look at get. Yeah, so get takes a URL string. It'll go get an OAuth token, which we'll look at later. This particular API requires you to put the client ID in the header as well, not just the access token. This is going to return a byte array. That's fine. Where's the part? Okay, here we go. So when I have the response body as a byte array, I do this action json.unmarshal. If we go look at what JSON is included with the Golang standard library here. And when I call unmarshal, I give it the byte array, and I pass in this user's response. This is just a pointer to this struct which I've instantiated. And we can see here that a user's response is just an array of these API videos. It's saying, hey, there's going to be a field in the JSON called data. Please go get them from there. Also, since this is an array, it's going to expect data to be an array in the JSON. And an API video has these fields that are going to be pulled from the JSON. So it's going to be digging through that data array and pulling out ID, user ID, publish stat. These are all strings, and it's going to be sticking them in one of these API video structs for every video that it found. And this is how you get from raw JSON to a data structure that you can work with. I'm sorry. That's user's response, but you can take everything I just said and apply it to video's response here. I was actually talking about how it's going to go get the users, but the video's response is right here. It's the same mechanism. Okay. So the next thing I do, this is another thing I've learned in Golang. I want to go ahead and mutate the video's data structures. You can see here on the right that I've got start and end. These are time instances, and they don't come from the JSON. You can see that there's no, I forget what they call these special strings, but I didn't put them for these two fields, so they're not going to come from the JSON. You can see here on the left that I assigned to start, and then a moment later I assigned to end. I do a simple parsing of the published at time and that's just, I just go from a string representation of when this video started to a time instance. But since I'm gonna do this assignment, I have to have a pointer to the video. That's why, like, instead of doing video like something like this, like, you might be tempted to do that, but I'm pretty sure that won't work. If you do that, I've had this happen to me a couple times. When you're iterating through an array, you get a deep copy. When you do that, and then you'll mutate the deep copy, and your original array won't be changed at all, which is, it defeats the purpose of what you're doing. So you have to get a pointer like this. You have to say, hey, give me the ith video and get me a pointer to it. And then you can start saying video start equals whatever. And then when you return these things, which is what I'm doing here, your mutations will have taken effect. So that's another thing that I've learned. Let's look at the OAuth. There's a OAuth 2 library that you can go grab. This seems like a standard resource in Golang. I'm using the client credentials flow of OAuth because, like, I don't need a user's permission to go get their publicly listed videos. What I wanted to show is how this thing in the OAuth 2 library called reuse token source. What you can do is load a token from a file. I think that's just a that's just a standard JSON unmarshal. I'm storing the token as JSON and I'm unmarshalling it here to get a token, and I return it. So I get that token. I can construct a config struct with my client ID and client secret, and then where to get new tokens. And I make a token source with that, but I can also do this reuse token source. And what you do is you give it a token, you give it the token source you built, and it'll check the expiry of this token every time you ask for one. So there's another function here called getToken, and what I'm doing, I'm checking if I have a token source. If I don't, I'm building one, and then I'm calling token on it. And since this is a reused token source, that'll check the token that you passed in, and if it's expired, it'll go use this token source to get a new one. If it hasn't expired, it'll just return the one that's still good, the one that hasn't expired. So it's really handy. I have some logic down here to write it to disk if I've detected that I actually got a new one. I'm used to working with the Ruby OAuth 2 library, and I haven't seen this in the Ruby library. I usually have to do that myself. Well, that's kind of it. Oh, let's talk about the web server for a second. So, how do you build a web server in Go? This is a web server in like 73 lines. Obviously, there's a bunch of reused code that the CLI uses. What do we really need to do the web server? I init the package like normal. There's this global that I'm using called renderer. It's going to use this render. It's going to be an instance of render.render, which is coming from this library here. This is a really basic templating library. I configure this renderer here. I assign to it. I say, hey, please use web app views as my directory of views. And if we go look at that, there's a web app views directory here. If I go in there, you'll see that I have some .temple files, and those look like HTML. So I'm saying, hey, please find my templates in there, and my layout will be application. That means that inside of this layouts folder, it'll use this application as the generic layout, you can see here that I'm going to pull in Bootstrap from a CDN, JS deliver. I'm going to actually, this is the interpolation that this library makes possible. I'm using it to assign to some JavaScript variables. And then down here I call yield, which hands it off to whatever specific template is being requested. So this is the handler of the root rendering action. All this does is say, hey, Mr. Renderer, please render the index.temple, which means that this yield will go to index.temple and it'll spit out this HTML. There are two functions here. One is root, one is called lookup. You can see that at the end of lookup, there's another call to render lookup, which is this HTML. It's very plain. There are actually 3 calls in this handler. So what are these? How do these functions get related to doing work? Well, you can say HTTP handle. HTTP is just a library in Golang. You can see hit here net/HTTP. You could say please handle the root path with root and the lookup path with lookup. You pass in your little functions, and those functions will execute. They'll get a pointer to a response writer and to the request. You can see here for lookup that I'm actually gonna go get the get query parameter called timestamp with this. So that's how you can get your get params. That's all I'm really using in this application. I have another get action here to get the username. You just call listen and serve when you've configured your handlers, and this will block. So that's how I have this running. For doing that variable interpolation, you have to create, like what I'm doing is I'm creating a map from string to interface. I haven't done, I just copied this from Relio code, so I don't remember exactly how this works, but you can say, oh, hey, I want video URL to equal the following string, and up here, it'll output that string inside of some quotes that I've stuck in here. I have a little DOM content loaded handler. I'm not using jQuery. In this day and age, you can often write your code without using jQuery. I'm saying, hey, let's go down to this error handling. If my error is not equal to the empty string, and how can that happen? Well, for example, if we went to parse the time and we got a nil, it'll say, hey, I want error to be failed to parse timestamp. I could probably get rid of this sprintf, but whatever. And then we come in here and we say, hey, find the alerts container, create a new div, create a new text node, which is going to have the error, and modify the class list to have alert and alert danger. Those are classes that mean something to Bootstrap, so it'll make your alert look pretty, and then you can append it to the alerts. So that's how it's like a really generic handling of errors, regardless of which page I'm on, since I'm in the layout here. And then to show the result, I say, look for a DOM node having the class result holder, which will exist if I'm rendering the lookup template. And then if I have one, I say, okay, let's check if my video URL is not the empty string. If it's not the empty string, create an A node, set its href equal to the video URL, and go ahead and add it to the DOM. Otherwise, create a text node that says no video found. And that's how I output the resulting video that I've dug up via the API. So that's like what's going on the client side in this web app. So it's a really small app. It's like 500 lines or so. I really like writing in Golang. It feels really liberating because I have the static type checker on my side. If my code compiles, there's a really good chance that it's going to work. Whereas, I mean, this is like, I'm not really doing interesting processes yet in this app. So sure, if I was, I'd probably want to write unit tests for those. It's a similar feeling in TypeScript. In TypeScript, if your code compiles, you feel really good, like you feel like you've done something. Whereas in Ruby, if your code passes the syntax check, it doesn't mean anything. Your code could still be full of bugs and just like stupid bugs too, like misspellings, and you don't find that out until you interact with your web app, which is really slow. So it's really, I feel like I'm building something more beautiful when I write in Golang than if I write in Ruby, because when I write in Ruby, is the thing I'm building, is it really as stable as it could be? Like at all times as a programmer, I would think that you want to do things in such a way so that you know about errors as fast as possible. And if you're waiting for a unit test to tell you about a simple error in Ruby, how can you say that that's the fastest way you can know you have an error? Like, that's just not true. So it would be nice, I think, if Golang had more people who are interested in it, but that's not really the reality. I was thinking of using this library to do my web work, and it was they archived the library because the community is so dead. This isn't the only project I've seen this happen in. I was thinking of writing some user interface code using Qt and Go, and there's a Qt wrapper that's also been archived, or like at least when I checked about a year or two ago, no one seemed to be maintaining it. So this is weird to me. It's weird and it's sad, but whatever. Hope you like this.